Hello everybody. We are going to get started in our robot project, which will take us to the next couple of weeks. So get ready for the 2014 Human versus Robot Showdown. Let's go ahead and get started. This video, this homework assignment, is really just to introduce you to the project itself and introduce you to the basics of computer programming, which is really the core lesson or one of the core lessons about this project. The first few slides are going to talk about the format of the project, who you're going to be working with, how it's going to be structured, what the roles are. In the second half of this video, we'll go through a very brief tutorial on the basics of computer programming, specifically in a program called Robot C. It's very similar to Java programming language, so for those of you who have some experience, this should not be very difficult at all. So how does this project work? Well, each robot will be built by an 8-person team. Though that 8-person team, now there are going to be a couple of exceptions. I think there's 2 actual teams of 9, but most of you guys will be working in teams of 8. These 8-person teams have actually been broken up into 2 sub-teams and 2 different blocks, which means we would have 4 people in, say, A block and 4 people in D block, okay? So you guys are going to be working in tandem with one another and building off of each other's progress. So if you let somebody down, you're not just letting your 3 other people down in your immediate team, you're letting the other block down as well. So everyone needs to step up their game and come with it every day because we don't have a lot of time for this project. Each sub-team, so each block of 4 or 5 kids to make up your total team, will have 4 members. Builder A, Builder B, Computer Engineer, and Mechanical Engineer. So that means there will be 2 Builder A's, one of them will be in Block A, one of them would be in Block D, 2 Builder B's, 2 Computer Engineers, 2 Mechanical Engineers. We broke it up this way because that way we can actually achieve all of this within the 4-day time period we've allotted for this project. So the goal, what our end product needs to look like, is we are looking at building a robot from technical instructions and from scratch, and then we have to program that robot to navigate around 2 obstacles and reach a determined end point. So it should be a lot of fun. Let's go into each individual role on there a little bit in more detail to give you some background on what to expect. The builders, obviously, you know, not too inventive on the name there, but you guys are responsible for building the actual robot. Beyond the initial construction of the robot, you will also be tasked with maintaining the robot during runs. Now your job is very, very important. If a screw gets loose and falls out and then you don't fix it, I take points off. Your job is to maintain and build this robot properly. So who would make a good builder? Someone who's very good at reading technical instructions, someone that can work quickly and independently without constantly being reminded, hey, get on task. A mindful person, okay? Someone that doesn't forget things very easily. If you forget to plug in your robot at the end of the class and the next block does not have a charged robot to practice with or to program, you guys get points deducted, okay? You must keep track of all of the small parts. Again, I do not want to come picking up after you from screws or nuts or bolts or whatever because you were not mindful of those small parts. And again, you will lose points if that happens. One of the most important parts to the builder's job actually occurs after the project is over. Now we're going to run these robots as soon as we come back from Thanksgiving break, but then after that, after the robots are run, the builders are responsible for coming back in and disassembling the robot. If you do not disassemble the robot and you make me do it, you will lose many, many points because that is part of your job. You have 3 main jobs: build the robot correctly, maintain the robot, and disassemble the robot. So if you forget to disassemble it, that's an issue. Okay? So builders, responsible. You guys are all going to have to be responsible on this, and you're going to have to be focused because there's not a lot of time. All right? Now the computer programmer, everybody in homework 1 at the end of this particular homework, everyone will be writing their first computer programming. We'll then get in class and we'll figure out who really likes doing that type of stuff, and then you will become the computer programmer. Okay, and you guys will figure that out amongst yourselves. Now the job of the computer programmer is to write the final computer program that makes the robot do what it's supposed to do. You will continue to tweak the program as needed. I guarantee you're going to run into some issues even if you do all of your math correctly. Okay, that's life. So you are going to have to be able to fix bugs, troubleshoot, think on your feet, and on down the line. Okay, a couple of basic requirements for a computer programmer is you must have a reliable computer. My computer is in help desk, or my computer is broken, is not a valid excuse for this project. So you need to pick someone that has a very reliable computer that doesn't need a lot of assistance from the help desk. Remember, not a lot of time on this project, so you need to come prepared every day, no matter what, no excuses. And obviously you need to like computer programming because that's what you're going to be doing. And finally, we have the mechanical engineer. The mechanical engineer will be calculating the steps needed to complete the robot challenge. Qualifications for a mechanical engineer is they must be good at math, they must be able to keep good notes, and they must be able to communicate with the computer programmer. So if you are going to bicker with the computer programmer and your personalities don't gel, then you need to figure out either how to deal with that or not work with each other directly. A mechanical engineer and computer engineer must be able to communicate efficiently and effectively. Okay? No arguing, no bickering, stay focused. So let's go through a very basic tutorial on programming in the program we'll use called Robot C. So the programming basics. All programs in Robot C must begin with this phrase: task, main, and then open and close parentheses. Now in coding, spacing and capitalization really matter. If you remove the space between task and main, program's not going to work. If you capitalize task and main, program's not going to work. Okay? In this computer program, all words are lowercase, except for there's one M in the wait command, which I will show you. That's the only place for capitalization. There is no space between the N and the open parentheses. There is no space between the open parentheses and the closed parentheses. This is called syntax, and syntax is vital to make a computer programming work. You don't get points off, your program just doesn't work. Okay? So just like in real life, real computer programming, syntax is vital. And what this phrase does, this task main phrase, is it tells the robot, guess what? We're going to tell you to do something coming up. So look out for that. So that's really just sort of a header, a red flag in the ground of the computer chips, if you will, saying something's coming up. The next line will have an open squiggly bracket. Now you can find that. It's next to the P button on your keyboard. And to enter that, it's the Shift. So you hold down Shift and push the button next to the P. All right, next to the letter P. So that'll open up your squiggly brackets. And then this says, remember that code that we were telling you about, the commands that were coming up? Here are the start of the commands. So that's what that tells you. Underneath that, you can enter in a few times if you want. You enter in all the lines of code. And the only commands we're really giving the robots is move your motor, and then move your motor for a certain amount of time. Okay? Now this robot has two motors, and we'll talk about that in a second. And you'll see the lines of code. It's not complicated. It's basically the same structure or framework over and over and over again. Okay? Every bit of code, every line of code, and make sure you know this because most basic computer programming errors are due to something simple like this. And this goes back to that syntax. All the lines of code will have a semicolon at the end of it. All right, that's a little button next to the L letter on your keyboard. No shift involved. That is where the semicolon button is. That says, my line of code is done. Please move on to the next command. All right. And then when you're done writing all of the commands for this particular program, you're going to have a closed end squiggly bracket. And again, it's right next to the other one. You will have to push Shift to get the squiggly part. All right. So those are the basic frameworks or structures all programs will have. And this is kind of what it looks like in Robot C. You will see it is color coded, and as long as you see this types of color coding, you know you have a correct line of code. If this is, I believe, if it just stays black text, then something is wrong with that line of code. So you're going to start your program off with task space main open and close parentheses and then enter, open squiggly brackets, and then this is the basic set of commands. Okay, so port 1, that is where your builders, assuming they read the directions correctly, they literally will take a cord and plug motor 1 into port 1 of the cortex. And that's really like, it's the robot's cerebrum, if you will. It's the brain or the thinking center of the robot. In essence, it's just a CPU, but you know, we like to use fancy words. So port 1 is left, and port 10 is right. So there's two motors, a left motor and a right motor, okay? The structure is simple. Lowercase motor, open square brackets. Now that's the same button as you get the squirrely, the little squiggly brackets, these things, but you don't have to push shift to get them, okay? So open square bracket, and then port 1, so I'm saying left motor basically. So port 1, and then close the bracket, equal sign, and then a number. The number will range from 0 to 127. That's the highest output. And what this says is, I believe, and this is a guess, I didn't do any background research like I should have, but I'm believing it's not a percentage. It's not 0% to 100%. It's really just revolutions per minute, I think. You can look it up and get a laugh if I'm wrong. You can say, oh, I got you wrong, Mr. Carmelo. But my guess is it's revolutions per minute because it doesn't make sense otherwise. You can't have 127% in a motor. But I could be wrong. Anyway, so this is just the power, how much power you have. So right now this guy is maxed out. It'll go as fast as it can. We'll talk about the negative sign coming up. That is important, but we'll talk about that on a later slide. So if this negative sign was not there, okay, and it just looked like 127 on both, what you're saying is, hey, left motor, go forward at 127 or full power. And then the right motor is saying, hey, go forward at 127 or full power. This negative sign just means go in reverse. It's a directional. So if it's a positive number, it means go forward. If it's a negative number, it means go backwards. All right. Now, to make a robot function, you must put a command for both motors at all times. So you're going to have a lot of this setup, okay? A lot of this setup where you have these three lines of code. So this tells you the power of the motor on the left. This tells you the power on the motor on the right. And this third line of code where it says wait, the number 1, a capital M. Remember, this is the only place you're going to see a capital letter when you're writing these codes. And then second, so this is wait 1 millisecond, and then function for this amount of time, okay? Your robots don't have a reader or a sensor to detect distance, but it can track time. So you're going to have to tell it to run these motors for a certain amount of time. And these time frames are all in milliseconds. So 1,000 milliseconds is equal to 1 second. 5,000 milliseconds would be equal to 5 seconds, okay? So just so you guys are familiar with that. So again, all programs, all single movements will have 3 lines of code. It'll have how strong the left motor is, how strong the right motor is, and how long we want those motors to move for. And this is just some review of that. Again, it's Robot C is a computer programming language. It comes with the 2 types of commands we're going to work with. It does have a lot more, but the 2 we're going to work with is the movement and the wait. So motor and the time you're doing it. So the motor, again, the function is there. Lowercase motor, open square bracket, port 1 would be the left motor, port 10 would be the right motor, and 89 or whatever the number is, that's the strength of the motor. And then your wait command, this wait 1 millisecond command, that is just, that's the time. So you're telling it to function for a certain amount of time. And now there are 2 main ways to make turns. So you can put your robot going in a straight line, and that would be motor port 1 equals 50, motor port 10 equals 50. If this was 50 in here and not 0, you're telling the robot to move at half strength, roughly, and you're going to tell them to move it for 4 seconds. So again, 4,000 milliseconds equals 4 seconds. You can see the syntax is correct here, lowercase everything, 1 space in between task and main, no spaces between the N and the parentheses, open squiggly bracket, close squiggly bracket. Syntax is important. Remember these semicolons at the end of each line of code. Those are important, all right? So there are 2 main ways to make a turn. You can either do a wide turn or a sharp turn. All right, and a wide turn is going to look something like a banana. Whee, and it's going to turn to the right. This line of code, this section of code, is saying move to the right or turn right, and we're going to do a wide turn. And the difference between this and the sharp turn over here is this line of code. All right, so that we're saying to the left motor, go at half strength. So left motor, go at half strength at 50. Right motor, let's initial it, a right motor goes at 0. So that means it doesn't move at all. They are static. So you're going to drag the right wheel. So if these are the wheels, here's my robot, and these are the wheels. These guys turn, these guys stay still. You're going to get this wide banana-shaped turn. Okay? Hopefully that makes sense. So that's a wide turn. To make a wide turn, you're just going to move whichever direction you want to turn in. You're going to turn that motor off. So in this case, we turned the right motor off for 4 seconds, and that's going to allow us or make us move in the right direction. If you want to turn left, then you would make this guy 0 and this guy whatever power, and now the right wheels are going to continue to turn, the left wheels will drag, and they'll banana out to the left. Okay? Now over here for the sharp turn, this is where your negative numbers come into importance. Okay? So we're saying to the left wheels, because port 1 is left, remember. Here's our robot, a really crappily drawn robot. Left wheels, you're going to go forward at 50 power. Right wheels, you're going to go negative 50, so that means you're going to go backwards 50 power. And what that's going to do is cause basically the robot to pivot to the right. So it's going to look more like that versus that big banana shape. Okay? So it's going to turn in a much sharper radius or a much smaller radius. Okay? So that is how you do a sharp turn and a wide turn. Now your packet has a small computer program that we're going to ask you to write, and that is the end of your homework 1. Once you have completed that computer programming task in your homework packet. So complete that now, and then write your first program, and I will see you in class tomorrow.